Hello everyone, welcome back for inequalities. Well, someone may be wondering what are the inequalities. Okay, inequalities, these are mathematical symbols which work in the same way as equations. The main difference is that inequalities are mathematical symbols which means to do comparison, that which one is bigger than the other or which one is smaller than the other. So this inequality is known as greater than, and this inequality over here is known as smaller than. For example, if I want to compare two numbers, which is 5 and -5, I find that 5 is bigger than -5. See? So that is one way of comparison. Another one can say that -5 is less than 5. So somebody can say -5 is less than 5. See that? So that is all the way about inequalities. Now, suppose I have two equal numbers. One number is 5, another number is 5. Then do you think I can get an inequality which can compare 5 and 5? All right. Somebody can say 5 is greater or equal to 5. So this sentence is correct. Why? Because there are two English words here. One is greater than. So 5 is not equal to, 5 is not greater than 5, but 5 equals to 5. That is why we say 5, if not greater than 5, but it will be equal to 5. So this inequality over here is known as greater than or equal to. So there are two English words there. Another one is, for example, you want to compare the same numbers, 5 here, another number is here. So somebody can say 5 is less than or equal to 5. Okay, so if it's not less than, then it will be equal to 5. Right, so there are two English words over here. So 5 is less than or equal to 5. So this sentence is correct. Now let us go to solving inequalities. That is the main important part of this discussion. Let's start with this question here. This is a worked example. The question says the perimeter of this triangle you see here is at least 50 centimeters. Write down an inequality to show this. The word perimeter simply means adding all sides. Now a triangle has 3 sides, so I'm going to add all these sides. That means x centimeter plus x plus 2 centimeter, then plus x plus 3 centimeters, then that will be your perimeter. So perimeter is adding all the sides. So what we do here is take this side, which is x, ignore the centimeters here, ignore that, then add it to x plus 2. So add x plus 2, then add again x plus 3. But they're telling you the perimeter of this triangle is at least. Now, at least, the English word at least is the same as the inequality greater than or equal to. So this perimeter will be greater than or equal to 50. See? Now, the word at least is replaced by the mathematical symbol, which is greater than or equal to. So write down an inequality to show this information. This is our final answer. Solve the inequality. Okay, we want to solve this inequality. What we do, the inequality is x plus 2 plus x plus 3 is greater or equal to 50. To solve the inequality is done in the same way as the way we solve equations. That means we need to collect like terms. So we have 1x here, we have 1x here, we have 1x here. So 1x plus 1x plus 1x, this will be 3x. Okay, now we have these numbers without the letter. We have positive 2 plus 3, this will be positive 5. It's greater or equal to 50. This positive 5 will be shifted to this side, and because this is positive, that will be minus 5. So this will be 3x is greater or equal to 50 minus 5. Can you see that? Now you do 3x, let us try to continue here. You do 3x is greater or equal to 50 minus 5, that is 45. So divide by 3, you are going to get that x is any number which is greater or equal to 15. See? This is the solution set for the inequality. Okay? Now, part C is show the solution set. We have to show the solution set on a number line. The solution set we got is x is greater or equal to 15. Now we want to show this solution set on the number line. So what we do, we draw a number line. This is our number line. And we concentrate on this number here. The number over here is 15. And the solution set suggests that x, where x stands for any number, which is greater or equal to 15. So the numbers which are greater than 15 are the ones which will be appearing on the number line. These numbers which are greater than, the numbers which are greater than 15 are 16, 17, 18, 19, 20, 21, 22. Can you see an arrow here? This means that these numbers which are greater than 15 are plenty of. They go to infinity. They go to infinity. Okay, now remember our starting number is 15. Now from 15 here, do you notice that it says greater or equal? Now I will be introducing to you what we call open circle, which we draw it that way, and also a closed circle, which we draw it in the same way, but we have to shade this to show that this is what we call a closed circle. Now, when do we use an open circle? We use an open circle when the solution set takes use of this symbol, this mathematical symbol. So if it is greater than or if it is less than, we use an open circle. And when it is this symbol, greater than or equal to, or less than or equal to, we use a closed circle. Now, where do we draw either an open circle or a closed circle? We draw an open circle or a closed circle with or at the number given. The number given here in the solution set is 15. So at the number 15 is where we draw an open or a closed circle. Now, in this case, we are going to use a closed circle. Why a closed circle? Because the inequality over here is greater than or equal to. So on top of the number 15, this is the number 15, we draw a closed circle. Just above the number itself, just above the number 15 itself on a number line. And then we take a ruler, we draw to highlight. Here they need all numbers which are bigger than 15, starting with 15 itself. So all numbers which are bigger than 15 starts from here and extend to the right hand side. Can you see that? Okay. Now, after that, what do we do next? Normally, after drawing this, we label that this is x, where x stands for any number which is bigger or equal to 15. Okay. I hope that is clear. Let us go to the next question here. Write down an inequality to describe each of these solution sets. Okay. Now, here we are given the number line. On this number line, we are given a closed circle. Now, this closed circle implies these two mathematical symbols, greater than or equal to, or less than or equal to. So that means to write down an inequality to describe each of these solution sets, so we have already figured out that our inequality will take use of either greater than or equal to. If not greater than or equal to, it should be taking use of less than or equal to. Now, if you notice that the number line starts from 2. Can you see that? It starts with 2. Now, it starts with 2, but it heads to the left-hand side. So that suggests that this inequality will be representing all numbers which are less than 2. So all those numbers are represented by using a letter X. So when you see letter X, this implies all numbers which are less than 2. But remember what I said? I said that when you see a closed circle, that implies either greater than or equal to or less than or equal to. So in our case here, the inequality will be X, where X stands for any number, is less or equal to 2. Can you see that? X stands for all numbers which are less than or equal to 2, all these numbers. From here, going to the left-hand side. All these numbers from here, going to the left-hand side. So this is the inequality which we use. Okay. So here, the inequality which they're looking for is all numbers which are less than or equal to 2. Okay. I hope that helps. Let us move on. Part B, you can see something we call open circle. Can you see that? Open circle. Now, open circle suggests open circle suggests either this inequality or that inequality. Now, can you see the starting point? The starting point of this open circle begins with -2. So our number to start here is -2. But if you check the arrow starts with -2 and then it goes to the right hand side of -2. So what does it imply? It means that -2 is less than all these numbers you see here. -2 is less than all those numbers. Negative, if you consider like 0 is bigger than -2, 2 is bigger than -2, 4 is bigger than -2, 8 is bigger than -2. So -2, our inequality will be -2 is less than all those numbers I was mentioning. Now, to summarize all those numbers, we use the letter x. So that means -2 is less than numbers that I have talked about, which are 0, 2, 4, 6, 8, and so on. Okay, so A and B, they are all done. Then let us go to C. Now, for the case of part C, we have a closed circle. Now remember what I said for closed circle? For closed circle, I said that suggests greater than or equal to. That is one of the inequalities. Another inequality will be less than or equal to. Now let us see, are we going to use this one or this one? Let us see the direction of the arrow. The direction of the arrow begins with 10. So you write 10 here. And once it begins with 10, it goes to the right hand side of 10. That means this inequality or this arrow is occupying all numbers which are bigger than 10. Numbers like 15, numbers like 20, numbers like 21, numbers like 22. They are all bigger than 10. In other words, 10 is less than those all numbers I was talking about, which are 15, 20, but we can't mention them. We can't list them all. That is why we use a letter X. This letter stands for all numbers which are bigger than 10. So in that case, 10 is less than those numbers. Now remember what I said? Can you see a closed circle? So that will imply 10 is less or equal to X. Okay, come on to this question part D. We can notice that the number line or the arrow begins with -20. Okay, now it is beginning with the -20 and proceed to the left hand side, occupying numbers like -30, -40, -50, -60, -70, and so on. So what does it mean? It means that these numbers here, -30, -40, -50, to the left of -20, they are all less than -20. So all those numbers are less than -20, and the symbol which we use to summarize all of those numbers which are less than 20, the symbol or the letter is X. Here X stands for all numbers which are less than -20. Okay, that is our inequality. Okay, now why did I use less than and not less than or equal to? It is because you can see something which I was talking about, an open circle. This is an open circle. All right, hope that is clear. Now let us, okay, now here we try to assume that we have solved the inequality, and this is the final answer. This is the solution set. X is bigger than 3 for part E, that is for part A. For part B, we have x is less or equal to -3, and for part C, we have x is less than 0, and for part D, we have x is bigger than -20, bigger or equal to -20. Remember what I said? I said, and I quote myself, x stands for any number. X stands for any number. Okay. Now the question is, show each of these solution sets on a number line. Okay, so we need to draw a number line. We need to draw a number line. Okay, so here you draw a number line. Okay, now this number line begins with 3. And here they are talking about all numbers which are bigger than 3. So the numbers which are bigger than 3, are 4, 5, 6, 7, and they go to infinity. See that? They go to infinity. Okay, now, how do we show this on a number line? You have to begin with a number itself. The number itself is 3. Now, can you notice that we have this symbol greater than? Now, should we use open circle or should we use closed circle? I said for this symbol greater than, we use open circle. Now, where do we draw an open circle? We draw an open circle on a number 3 itself. So just above, don't draw somewhere here, no. We draw just above the number. We draw just above the number, just above the number itself. So make sure that it is really open circle. Okay. Now where do we head to? Remember what I said? I said that we start from the number 3 going to the right hand side. Going to the right hand side. Can you see that? Good. So we start from the number itself and we continue to infinity. Okay. So we start from here. And why an open circle? Because it is greater than. So all numbers which are greater than 3 are 4, 5, 6, 7, and so on. So this is where we write x is greater than 3. How about part B? Part B, what we do, we pull out a number line. Draw a number line over here. That looks massive. Okay, let us make it a little bit that. All right, so here we are talking about x is less or equal to -3. Remember what I said? X stands for any number that is less than -3. So the start point is -3, and we have to look for all numbers which are less than -3. So on this number line, my interest is -3. So -3 comes here, and then you have numbers, all numbers which are less than -3. All numbers which are less than -3 are found on the left hand side of -3. That is -4, that is -5, that is -6, that is -7, but they don't end here, they go to infinity. That is why we have this arrow over here. Okay, now, do you notice this? This is less than or equal to, which we are going to use a closed circle. But where do we draw that closed circle? We draw a closed circle on -3. Closed circle on -3. Just above -3, you draw a closed circle, and we have seen that the numbers are from here. 1 minute. Okay. So the numbers are from here. Nope. Let me change that. Okay, so let me change this. All right, so all the numbers from here, from the closed circle going to the left hand side. See that? Those are the numbers we are talking about. And here you have to write that this is x should be less or equal to -3. All right, let's go to part C. Part C is talking about all numbers which are less than 0, all numbers which are less than 0, and the sign here is less than, which suggests open circle. Okay, so we pull out the number line, draw a number line over here, number line, the number line like so, and then we have numbers. We are trying to identify all numbers which are less than 0. So the reference point is 0. The reference point is 0, and we have to show all numbers which are less than 0. Okay, so if we put our 0 here, if we go on the right hand side of 0, we are getting numbers like 1, 2, 3, 4, 5, which are bigger than 0. But here, the concern is x, where x is all numbers which are less than 0. So all numbers which are less than 0 will be -1. On the left of 0, -2. To the left of 0, -3. To the left of 0, -4, and so on. Now, where do we draw the open circle? Open circle, you really know what it means. Okay, where do we draw the open circle? The open circle is drawn on a 0 itself. So open circle just above a 0. And then you take your ruler, you draw a line. Okay, take your ruler, draw a line going to the left hand side. Can you see that? And that is an open circle. And here you write x, or all numbers which are less than 0. All right, so I can let you try this as your homework. Try that as your homework. All right, let's go to the next part. The next question is any is an integer. Any is an integer. Do you remember what it means by integer? An integer is a set which contains numbers like 0, positive numbers like 1, 2, 3, 4, 5, etc. Also, an integer is a set of numbers which also include the negative numbers, -2, -3, -4, -5, etc. You see that? So in a set of integer, when they say an integer, we don't expect to have a decimal number in a set of integers. Only whole numbers positive, whole numbers negative, including a 0 that is a set that is making up a set of integers. So, question A. The question is, work out the smallest possible value of n if n is greater or equal to 6.5. Now, greater than 6.5, numbers which are greater than 6.5, numbers which are greater than or equal to 6.5 are, work out the smallest possible value of an integer n which is greater than 6.5. Now, let us see the numbers or the integers which are greater than 6.5. Those integers which are greater than 6.5 are 7, 8, 9, 10, 11, 12, and so on. These are numbers which are greater than or equal to 6.5. Okay. Why do you think I did not start with? Because when it says greater than or equal to 6.5, that means you have to start with the number itself, 6.5. Now, I did not start with 6.5 because 6.5 is not an integer. An integer is a whole number. That's why I have begun with 7. Now, the question is, what is the smallest possible value of n? Now, the smallest from this list here, the smallest is 7. The smallest is 7. So here, the smallest from that list is 7. Okay, I hope that is clear. The smallest number in that list is 7. Okay, now, B. What is the largest possible value of n? What is the largest possible value of n if n should be something less than -3? The largest possible value of n. Let us first mention what are possible value of all integers. Let us first work out the possible values of integers which are less than -3. Okay, integers which are less than -3, integers which are less than -3 include, integers which are less than -3 include -4, -5, -6, -7, etc. All those integers which are less than -3 are -4, -5, -6, -7, -8, -9, -10, and so on. Now, from this list here, which goes to infinity on the left-hand side, choose the largest of all. Now, the largest of all here will be -4. Now, this is where students get confused. -4 is bigger than -5. -4 is bigger than -6. -4 is bigger than -7. So the largest possible value, B, the largest possible value of n, where n is an integer, the largest value of n, which is less than -3, the largest value is -4. The largest value is -4. C. Work out the possible value of n if n is bigger than -2, this n, which is our integer, is bigger than -2. At the same time, it should be bigger than -2, and also it should be less than 2. These are two inequalities. These are two inequalities which are combined together. Work out the possible values. Work out the possible values of n if that n should be greater than or equal to -2, and such n should be less than 2. Okay, let me clear everything. Okay. The possible values of n if n is greater than or equal to -2. So the n should be greater than or equal to -2, and the same n should be less than 2. So you can combine this information like so. You can combine this information like this. That -2, the n should be bigger than -2. This is what they're talking about. N is greater than -2, and the same n should be less than 2. So you can combine that in this way. So here, how do we get the values? Now here, we have to identify. We have to identify all numbers which are within this interval. Okay. Now less or equal to -2. That means you start with -2 itself. Okay. Numbers which are bigger than -2 are -1. But these numbers have to continue going until it hits this one here. So -2, -1, 0, 1, and 2. But can you notice that this is less than 2, but not less than or equal to 2? So 2 will be omitted in our list. So in that case, we are trying to figure out all the integers which are within this interval here. Those integers are -2, -1, 0, and 1. See the set of values. All right, solve these inequalities. Okay, we want to solve these inequalities. How do we do this? Solving inequalities is done in the same way as how we solve equations. So here, expand the brackets. This will be 2a. 2 times 4 is 8, less than 15. Collect like terms. This positive 8 will be headed, will be shifted to the right hand side. This will be 2a is less than 15 minus 8. And this is 2a is less than 15 minus 8 equals to, that will be 15 minus 8. 15 minus 8, this will be 7. Okay, can you see that? 7. Now, to find the value of a, we need to divide by 2. We need to divide by 2. This will cancel. A is less than 3.5. This is the solution. How about this one? 3b minus 4 is greater than b plus 8. So what we do here is collect like terms. This b will be shifted here. -4 will be shifted there. So we are going to have 3b. B is positive, so it will be minus b equals to 18 plus 4. 3b minus 1b is 2b equals to 18 plus 4. This will be 22. To find the value of b, we need to divide by 2. Oh, crazy. Okay, this is, sorry for that. The inequality has to be maintained and not confused with an equal sign. So this will be 3b minus b, 3b minus b. Then this will be greater or equal to, this will be 18 plus 4. Now this will be 3b minus b, this will be 2b, is greater or equal to 18 plus 4, this will be 22. Divide by 2, divide by 2, this will be b is greater or equal to 11. Right, so I'm sorry for that. You know, the question looks to be crazy and confusing, so ignore that. Now let us go on. This will be, we also collect like terms. We have 2 C's. Oh, one question. This C is for the question. Okay, let us move on. So C, this C here, the negative C will be shifted on the left hand side, and the positive 18 will be shifted on the right hand side. Okay, so this will be C plus C is less or equal to 30 minus 18. 1C plus 1C, this is 2C. So less or equal to 30 minus 18, this will be 22. Let me check. 30 minus 18. Okay. That will be 12. Correct. So this will be 12. To find the value of C, we need to divide by 2. We need to divide by 2. C will be less or equal to 6 by 2, 1 by 2, 6. Okay, here we need first to expand brackets. 3 times d, 3 times 5, 2 times d, 2 times negative 6. So this will be 3d plus 15 is greater than 2d minus 12. Collect like terms, this will be 3d, 2d will come here, and it will be minus 2d is greater than, positive 15 will be headed to the right hand side, so it will be negative 12 minus 15. 3d minus 2d, this will be 1d is greater than negative 17. Okay, so this ends here. Because when you divide by 1 on both sides, still you remain with d is greater than negative 17. So here we stop. Okay, I hope that helps, so you can pause the video and start taking some notes. Otherwise, let us move on. Let me check how much time has gone. Okay, just less time. All right. Okay, let us try to go quickly. We have this question here. The perimeter of this triangle is not more than 30. Okay, the perimeter is adding all the sides. That is what we discussed. Ignore the centimeter, ignore the centimeter, ignore the centimeter. So write an inequality to show this. Okay. We have 2n plus 3, 2n plus 3 plus n plus 2n plus 2. That perimeter is not more than 30, so it should be less than 30. That is the inequality, so we stop there. Solve the inequality. Okay, so we need to solve this inequality. We have 2n plus 3. We have plus n. We have plus 2n plus 2. should be less than 30, we need to solve this inequality. Solving this inequality requires us to collect like terms. We have 2n plus 1n plus 2n, so we have 2n plus 1n plus 2n. We have plus 3 plus 2 should be less than 30. 2n plus 1n plus 2n, this will be 5n. 3 plus 2 is 5. This is less than 30. Collect like terms. 5 will be shifted over there, so it will be 5n is less than 30 minus 5. So 5n is less than 30 minus 5. This will be 25. To find the value of n, we need to divide by 5. Divide by 5. So our answer will be n is less than 5. Okay. Now, we have got n is less than 5. Now, what next? Let us try to see the part C. What are the largest possible lengths of the sides? What are the largest possible lengths of the sides? Okay, we got n is less than 5. But what does n stand for? If you read this question, say the perimeter of this triangle is not more than 50. The perimeter of this triangle should not be more than 30. Okay. So if the perimeter of this triangle has to be not more than 30, if you substitute n, because here n is any number which is less than 5. N should be any number less than 5. Now, a number which is less than 5, there are plenty of numbers which are less than 5. If this is 5, and this is 4, and this is 3, this is 2, we have plenty of numbers which are less than 5. Those numbers are numbers like 4.9, 4.8, 4.7, 4.6, and so on until 4. Then we have 3.9, 3.8, 3.7, and so on and so on. So how do we answer this question, that what is the largest, what are the largest possible lengths of the sides, whereby the perimeter should be not more than 30. Suppose you substitute n as 5 here. N equals 5. Here on this side you are going to have 2 times 5 plus 2. This side will be 2 times 5 is 10. 10 plus 2. This side will be 12 centimeters. And if I take n as 5, this side will be equal to 5, and this side will be 2n, which is 2 times 5 plus 3. This will be 10 plus 3. This will be 13. This side will be 13 centimeter, and this side will be 5 centimeter. Now, if you add these all sides, 12 plus 13 plus 5, what do you get? 12 plus 5 is 17. Okay, 17. Now 17 plus 13, you get 30. And here they're saying the perimeter of this triangle is not more than 30. Is not more than 30. Now when you add 12 plus 5 plus 18, you are getting something equal to 30. Now, what do you have to conclude? You can say, because the question is that the perimeter should not be more than 30, and we got something equal to 30. So that means the largest, what are the largest possible lengths of the sides? What are the largest possible lengths of the sides? The largest possible length of the sides will be, the largest of all will be 5, 12. Okay, let me check here. 2 times 5, yeah, will be 5. The largest possible will be 5 centimeters, will be 12 centimeters, and will be 13 centimeters. These are largest possible, because when you add them, you are getting something which is not more than 30. You are getting something equal to 30. So these are the largest possible lengths of the sides. In case of anything not clear, so you can drop me a comment so that I can come back to you and explain. Otherwise, we are done. Then let's go and check some more questions over here. The diagram shows 4 angles around a point. Okay. The diagram shows four angles around a point. Write down an inequality for x. Now remember that all angles around a point, add up to 360 degrees. Okay, add up to 360 degrees. So if you want to write an inequality using this diagram, that means when you take this angle plus this angle here plus this angle here, the answer you will get should be something less than 360 degrees, because this angle here is left behind. We don't know. So if you want to write an inequality for x, you'll be talking about this angle plus this angle plus this angle. That sum should be less than 360 degrees. I hope that is clear. Okay, so we take x, that angle, x degree, plus this angle here, which is 2x degree, plus this angle here, which is x plus 30. Now we have excluded this angle, so this sum should be something less than 360 degrees. This is the inequality which they are talking about. Solve the inequality. Okay, solve the inequality. We take x plus 2x plus x plus 30. It should be less than 360, because one angle to complete 360 is eliminated, or is not included. Okay, so correct like terms, we have 1x plus 2x plus 1x, 1x plus 2x plus 1x, that makes 4x plus 30 is less than 360. Okay, these are degrees. So 4x, this will be shifted to the right hand side. This will be less than 360 degrees minus 30 degrees. Okay, this will be 4x is less than 360 minus 360 minus 30. That will be 330 degrees. To find the value of x, you need to divide by 4. This will be x is less than 330 divided by 4. Okay, so 330 divided by 4, that will be equal to 82.5. So 82.5. So here we are talking about x will be any number that is less than 82.5. Now explain why the angle labeled x cannot be a right angle. Explain why the angle labeled x cannot be explain why the angle labeled x cannot be a right angle. Okay, let us try to refresh our memory. A right angle is equivalent to the size of an angle equal to 90 degrees. So the question is, explain why the angle labeled x can never be a right angle. That means can never be equal to 90 degrees. Now suppose this angle here is equal to a right angle. Explain why the angle labeled x is not 90 degrees. If this angle, if x has to be equal to 90 degrees, that means this angle will be 90 degrees. If x has to be a right angle, that means 90 degrees. This angle here, which is twice x, will be 2 times 90 degrees, will be 180 degrees. See that? Now if x has to be, say, a right angle, that means if x has to be 90 degrees, this angle here will be x plus 30, will be 90 plus 30, and this will be 120 degrees. Now what will happen? If x is a right angle, what will happen? If you take 90 plus 180 plus 120, you'll be getting something higher than 360. Let us do that. If you take 90 degrees plus 180 degrees plus 120 degrees, you'll be getting a result which is higher than 360 degrees. So 90 plus 180 plus 120, so the result 390 degrees. But remember what we said? Explain why the angle labeled x cannot be a right angle. Okay, explain why. This is because if x is a right angle, which is 90 degrees, if x is equal to 90 degrees, the sum of angles round a point will exceed 360. That is 390 degrees. Something which does not exist. Something not existing. Something not existing. Because we understand that all angles round a point should add up to 360 degrees, not something higher than 360 degrees. So that is why we say an angle labeled x can never be 90 degrees, because if x is 90 degrees, the sum of angles round a point will exceed 360. That is 390, something not existing. Okay, we have another question here. The length of the sides of this hexagon are in meters. Okay, they are in meters. So we can just say this is x plus 1 meter, x meter, x plus 1 meter, x plus 1 meter, and x meter. Okay. The perimeter is less than 50. Write an inequality for this. Okay, this, I hope I have talked about the perimeter. Is just adding all the sides, and less than 50, that means this will be the inequality to be used. So you can try this as your homework, but when you get stuck, I'm here to help. Solve the inequality you do in the same way. If x is an integer, find its largest possible value. Okay, because of this question, but see, let me do the whole question. The perimeter is less than 50, so what we do is adding all these sides for the perimeter. So let me start here. So take x plus 1, take x. I'm adding all the sides. That is what it means by perimeter. X plus 1 plus x plus x plus 1. Then stop there, because that now should be less than 50. This should be less than 50. This is the inequality. Solve the inequality. Okay. Solving the inequality involves collecting like terms. See that? See that? All right. So, how do we solve this inequality? Okay. We have x plus 1, x plus 1, x plus 1. That should be less than 50. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Correct. Okay. Now to solve the inequality, we need to collect like terms. We have x plus x, 1x plus 1x plus 1x plus 1x plus 1x plus 1x. 1, 2, 3, 4, 5, 6. So this will be 6x. Okay, we have positive 1, that will be 1 plus 1 is 2, plus 1 is 3, should be less than 50. Let me check. 2, 3, correct? So this 3 will be headed to the right hand side. This will be 6x less than 50 minus 3. This will be 6x is less than 50 minus 3. 50 minus 3 will be 47. Okay, find the value of x. We need to divide by 6. We need to divide by 6. So this will be x is less than 47 divide by 6. (47) divided by 6 will be equal to 7.8333 recurring. So 7.833. You can leave it here with some 3 decimal places. Okay, so I'm done with solving. Now the question is, if x is an integer, find the largest possible value. Okay, if x is an integer, find its largest possible value. We have x, we have, this is our solution set, this is our solution there, this is our solution set. We got x is less than 7.833. Now they are saying x is an integer. Find the largest possible value. Remember what I said about integers? Integers are whole numbers. Integers are whole numbers which are either positive, 0, or negative. See? Now, if we are to mention here, if x is an integer, if x is an integer, if we were to mention all integers which are less than 7 point, or integers which are less than 7.833, those integers which are less than 7.833 will be 7, will be 6, will be 5, will be 4, will be 3, will be 1, sorry, will be 2, will be 1, will be 0, etc. These are integers. These are integers which are less than 7.833. Now the question is, find its largest possible value. That means choose the largest from here, from this list. Now the largest of all is 7. So the largest possible value is 7. So here the largest possible value is 7. 7 is the largest of all. Okay, I hope that is clear. Let us go to the next question. How much time has gone? 1 hour, 5 minutes. All right, so I guess we better take a break, and then I'll be back for part 3. Bye-bye for now. Let us take a break. We have spent 1 hour, 6 minutes.